In this question, we're told that there are only R red counters and G green counters in a bag. A counter is taken at random from the bag. The probability that the counter is green is 3 out of 7. The counter is then put back in the bag. We're then told that 2 more red counters and 3 more green counters are put in the bag, and a counter is taken at random from the bag again. Now the probability that the counter is green this time is 6/13. And we need to find the number of red counters and the number of green counters in the bag originally. Now let's draw a table to help us visualize this. So in this table, we have the original probability of picking a green counter, the original probability of picking a red counter, the probability of picking a green counter after more counters were added, and the probability of picking a red counter after more counters were added. Well, now we're told that originally the probability that the counter is green is 3 out of 7. And so we can say that this probability is equal to 3x over 7x, because 3 out of 7 may be a simplified fraction, and so including the 3x over 7x helps us to find how many green counters there were in the bag. Now if the probability of picking a green counter is 3x out of 7x, the probability of picking a red counter would be 7x minus 3x out of 7x, and so the probability of picking a red counter originally is 4x out of 7x. Now we need to see the probability of picking a green counter after more counters were added. We're told that 2 more red counters and 3 more green counters are put in the bag, and so the total number of counters would be 7x plus 2 plus 3, which is equal to 7x plus 5. If 3 more green counters are added, then the probability of picking a green counter after the more counters are added would be equal to 3x plus 3 over 7x plus 5. And likewise, we're told that 2 more red counters are added, and so the probability of picking a red counter after more counters are added would be 4x plus 2 over 7x plus 5. Now looking back at the information in the question, we're also told that the probability that the counter is green after more counters are added is 6/13. Now looking at our table, the probability that the counter is green after more counters are added is 3x plus 3 over 7x plus 5. And so we can say that 3x plus 3 over 7x plus 5 is equal to 6 out of 13. Now we need to cross multiply. We can say that 13 multiplied by 3x plus 3 is equal to 6 multiplied by 7x plus 5. Now expanding these brackets, we can say that 39x plus 39 is equal to 42x plus 30. Now let's move the 39x over to the other side, and we're left with 39 is equal to 3x plus 30. Now taking 30 away from each side, we can say that 9 is equal to 3x. And so we can conclude that x is equal to 3. Now let's remind ourselves about what the question is actually asking us. We need to find the number of red counters and the number of green counters that were in the bag originally. Now looking at our table, the number of green counters originally in the bag would be 3x, and the number of red counters originally in the bag would be 4x. Now we found that x is equal to 3. And so let's start with the number of red counters. The number of red counters would be equal to 4x, which would be equal to 4 multiplied by 3, which is equal to 12. And then the number of green counters would be equal to 3x, which is 3 multiplied by 3, which is equal to 9. And so we've now found that the number of red counters that were initially in the bag is equal to 12, and the number of green counters initially in the bag is equal to 9. Now this question is worth 5 marks. We get the first mark for identifying that the number of green counters after more counters are added is equal to 3x plus 3 over 7x plus 5, and for identifying that the number of red counters after more counters are added is equal to 4x plus 2 over 7x plus 5. We get the second mark for saying that 3x plus 3 over 7x plus 5 is equal to 6/13. Then we get the third mark for cross multiplying and for finding that 39x plus 39 is equal to 42x plus 30. We then get the fourth mark for correctly solving and for finding that x is equal to 3. And finally, we get the fifth mark for substituting our value of x back into our original equations to find that the original number of red counters in the bag is equal to 4x, which is equal to 12, and the original number of green counters in the bag is equal to 3x, which is equal to 9. And so we've now achieved the full 5 marks needed in this question.